Thank you, Dr. Falk. And next we have Charles Venditti from the National Institute of Health.
Okay, I'd like to thank the organizers for inviting me to speak today about methylmalonic acidemia, which is a disorder I've been studying in the intramural research program since about 2003. I'm going to provide a digestible vignette joke about a study we have done looking at medical foods, really, in MMA. So I'm going to provide, let's see, let me get this to work here. That goes forward. Okay. No conflict of interest. Okay. So I was going to review MMA a bit for those who are not familiar with this condition and talk a little bit about management, discuss medical food use and the nutritional therapy of MMA, and finish up with some questions and comments for future research. So to go over MMA for the audience, methylmalonic acidemia, and let's just see if this works. Okay. Basically, this is a disorder of essentially of amino acid and odd-chain fatty acid metabolism in humans. We must oxidize our branch chains, leucine, isoleucine, and valine, eventually to end up with this metabolite here, propionyl coenzyme A, which by this reaction sequence I've shown you ends up as L-methylmalonyl-CoA, which then, by the action of the MUT enzyme, the methylmalonyl-CoA mutase enzyme, is isomerized and turns into succinyl coenzyme A and enters the Krebs cycle. Now, it's not quite so simple in terms of the reaction sequence, because to get active cofactor for the MUT enzyme, adenosylcobalamin, you must synthesize this from the diet. And I'm showing you an abbreviated schema of this pathway, where hydroxylcobalamin is eventually, by the action of multiple steps, converted to ADO-CBL. And if any of these steps are aberrant, or if patients have a mutation of any of these enzymes, they develop methylmalonic acidemia. And that's what we measure in the blood, urine, spinal fluid, and the tissues. I should say that these patients have absolutely massive elevations of MMA and the classical forms of MMA that we've been studying, as much as 10,000 times the upper limit of normal that you would measure in an otherwise healthy individual. So these are the extreme ends of the spectrum in terms of the metabolic perturbations you'll see related to vitamin B12 metabolism. So when a patient has MMA, I'm not going to review the clinical symptoms in great detail, but they're very similar to some of the things that Dr. Falk mentioned. These patients have a secondary mitochondriopathy syndrome, but it's very interesting in that it affects certain organs more than others. And then within a patient, some patients may only have certain symptoms, whereas other patients may have a full-blown syndrome. For example, some patients may have a dominant problem with pancreatitis, whereas other patients will not have this problem. All the patients eventually will develop chronic renal failure. And as I mentioned, there are variable manifestations of this, which makes it very difficult to manage. Most patients have poor growth and obesity. And we've published a paper on this in the American Journal of Clinical Nutrition describing our experience with the cohort. We studied it at NIH. What keeps all the physicians up and the families is that the patients have this phenomenon of metabolic instability, which is when they are subjected to stress of intercurrent infection or dietary indiscretion, they really literally can decompensate and die right in front of the faces of the emergency room staff. It's a very dangerous condition, and for this reason, the only real treatment that is offered to children with classical isolated MMA is the elective liver transplant procedure. So, to make a few comments about nutritional management, to treat MMA, as I alluded to, the definitive therapy is a gene or cell therapy that's going to give back the enzyme to the whole body and every cell. We're not there yet. We are working on this in the laboratory. As a proxy, we do a surgical gene therapy, which is liver or combined liver-kidney transplant. The thing that we all do to manage patients all around the world is medical nutritional management. And the reason this approach, quote unquote, works is because the metabolites derive, as I mentioned, from valine, isoleucine, and odd-chain fatty acids predominantly. These are propriogenic precursor amino acids, so we can restrict those in the diet. We can also give the patients antibiotics to sterilize their GI tracts, and that's going to reduce the amount of propionate coming from the GI tract, which will in turn then be fixed by the liver to make the metabolites, including MMA. And about 20 to 30% of the circulating MMA load in a patient comes from the gut. We can try to detoxify and relieve coenzyme A accretion by giving high doses of carnitine. I mean, some people give IV carnitine to these patients as high of doses as high as 200 milligrams per kilogram IV. So this is a very high dose. We can try to make the Krebs cycle work more efficiently by giving citrate. Whether or not this really has a real effect is unknown, but certainly you can get base equivalents produced by this approach. And then you can use mitochondrial targeted therapies, which I won't review. They were reviewed by Dr. Falk, to try to mitigate the ETC effects that we think possibly mediate the end organ pathology of this disorder. Patients are also prone to hyperammonemia, and there's ways that you can boost this by giving some patients carbaglu. So the topic that I'm going to really focus on today is the use of medical nutrition therapy to treat MMA. And so what this is really, go back, is we're going to be treating the patients, and this is uniform in many centers in the US and around the world, where the patients will receive a relatively low protein diet to restrict the propiogenic precursors. That's going to provide them with the complete or intact protein. And then we're going to add on, the communal will add on medical foods. And these medical foods have been formulated to have no valine, isoleucine, methionine, or threonine, because those are propiogenic amino acids. So the patients typically are managed by a combination of whatever they can tolerate plus medical foods. So we thought. I've provided these references for you because the vignette I'm providing with some expanded commentary derives from this, mainly the first paper. These were back-to-back in the Genetics of Medicine. And I'm going to go through these papers because I think it's an illustrative example about the use of medical foods and the treatment of an inborn error of metabolism. We started off with a very large cohort that we've been studying at the NIH. We're following about 200 patients with forms of MMA. This is very large for a disorder that has an incidence of about 1 in 100,000. And in our cohort, we had 60 patients with types of MMA. The MUT patients have the defect in the methylmalonic mutase enzyme, so they have genetic defects in MUT. Cobalamin A patients have an accessory factor to the synthesis of ADO-CBL, they're milder. And cobalamin B patients have a mutation in the enzyme that actually makes ADO-CBL. They all have isolated MMA. These patients came, what's unusual about this study is they came from all around the United States and even all around the world. So by using this cohort approach, we were able to look and examine patients in the inpatient setting as part of our natural history study at NIH and try to understand by retrospective analysis whether or not there's any patterns we could discern from the management of these patients based on their clinical phenotypes. Most of the patients that had MUT deficiency had a severe neonatal presentation. And when I say severe, I mean within the first days of life, they're in a coma, they're encephalopathic. And the statistics on dialysis are included in the paper. I don't remember them right now. The other thing I want to point out, too, is that this is very important for inborn errors of metabolism and thinking about how to do research. You have to be very careful when you characterize the patients. You need to know what their mutations are and their enzymology. To say someone just has the biochemical phenotype is not enough. And this is important when you try to compare outcomes between different patient groups from different centers around the world. They may not all have the same sort of sub-endophenotype of MMA, so you must do this. So this is really the result I want to spend a couple of seconds going over with the group here. So when we looked at our patients, and they're listed here by age, and then by the protein equivalent or weight, grams per kg per day, of their actual weight. Remember, these patients are obese and short, but we're not going to account for this. By the way, I should say we have DEXA scans on everybody, and then that's a separate set of commentary I can provide later. When we look at these patients, you can see here, there's the DRI protein we heard about earlier today. So you can see, and I can't really see so great on my screen, but you can see here there's some patients, for patients that are protein restricted, some are tolerating much beyond the DRI, and I should say that these patients are inactive, they don't have diarrhea, they don't have renal wasting syndromes, and they're not running around all day long, and if they have a movement disorder, they tend to be controlled. So they're not hypermetabolic. And when you add on the amount of total protein they get with medical foods, you can see that many patients were 200% of the RDI. So this is a massive amount for patients with these patients. And what was really peculiar about this group of patients when we did this analysis is that many of the patients received valine and isoleucine supplementation. Recall that I just mentioned that the toxic precursors of MMA derive from valine and isoleucine. So this is a major conundrum. Why is this happening? Why would a patient need more than DRI, medical foods, and get isoleucine and valine? It just doesn't make any sense at all. In addition, this amount of nitrogen is significant for patients that are prone to hyperammonemia. This is a concern for the patients. So, the questions are, why do the patients receive valine and isoleucine supplements? Why do they have 200% DRI and not grow? And could something related to the imbalance of branched-chain amino acid metabolism via the medical foods and dietary prescriptions contribute to these observations? Step one, what is in the formula? So here what I'm showing you here is the valine, isoleucine, and leucine content of breast milk versus infant formula. And recall that there's always a nice relationship between the amounts of valine, isoleucine, and leucine in foods, in natural foods. Here's our MMA formulas that we're giving the patients. Huge amounts of leucine, zero isoleucine and valine, because we don't want them to be propiogenic. Okay? Those are our young patients. How about our older patients? It's the same thing. Here's some different food items, and here you can see the different formulas. They have huge amounts of leucine in them. This is not normal. This is aberrant. So we went back and looked to see how much leucine the patients might be getting. And you can see here, some patients are getting 5 times the DRI of leucine, or 4 times the amount. And then you would say, well, maybe they're getting isoleucine and valine because they're deficient. They're not. They're actually getting more isoleucine and valine than DRI. And these are the WHO recommendation levels, by the way, for that age group. Okay, so maybe there's something methodologically aberrant. So what we did here was I'm going to spend a second to explain this medical records computer experiment that was done at NIH. So what you're looking at here is Oleg Shalachkov is a physician in the group, queried all the amino acid values of all patients at the NIH in a de-identified fashion to create a matrix, a correlation matrix, to see whether or not, if our methods are intact, we should see a correlation between the branch chains, just like everybody else has done forever and since we've been able to measure amino acid levels. And in fact, I'm showing you here the raw correlation values, and you can see these are just random patients. They might have cystinosis, or they might have obesity syndrome. They don't have MMA. They have something else. And you see this beautiful correlation. And when you look at our patients that receive medical foods, these same patients being measured in the same fashion, the correlation between leucine and valine is gone. We've altered the branched chain amino acid ratios in these patients somehow, probably through the medical foods, right? That's what makes the most sense to me. And if you look further and do correlative analysis, and I want to emphasize this is not causation, this is correlative analysis. You can see here that the more medical foods a patient takes in, the lower their levels of valine and isoleucine. And it's the same for patients when they get intact protein. Is there a correlation between these perturbed amino acid values and growth? Well, in this cohort, there seems to be. There's a correlation, and it's significant. The more medical foods a patient took, and the more aberrant the ratio, the more poor the growth was. Makes sense, right? And again, I'm going to emphasize, this is an association. This doesn't prove it, anything. It's an association. So, have other people ever seen this? The answer is yes. And when I say see this, what I'm specifically referring to is leucine effects on the levels of the plasma levels of other branch chains. And in fact, going back to the very original report by Dr. Dayan of 1961 of the first patient with propionic acidemia and some controls, and back then I think they listed in the paper they would have the patient's initials. We don't do that anymore. What you're looking at here is when they give the patient an IV bolus of either 250 or 125 mg per kg of leucine, and they start the infusion now, what will happen is the branch chains plummet. Whether the patient has propionic acidemia at the time they didn't know it was PA, or they have or controls. So it's been seen forever. If that's not enough, there's multiple papers on this. I'm just showing you an example here of a more recent report showing sort of the same thing, that when you increase leucine intake, valine and ILU go down. So what's going on? This is what we think is going on. We think that the unbalanced leucine load in these patients is promoting aberrant rechanneling of branched-chain amino acids, probably in the muscle beds. And you're sucking away your ILU and valine in the face of an unbalanced leucine load. Then someone measures the blood and sees that isoleucine and valine are low. So they say, supplement. And that's how the patients are ending up getting isoleucine and valine supplements, even though they're getting much too much protein, and some of them are getting much too much medical food. And so, as I said, the effects look like there's an effect on growth in these patients. And whether there's effects on the brain, this is a separate topic that I don't really want to dwell on, but leucine is a bioactive amino acid that can have effects on transport of other amino acids into the brain. So could this affect BBB uptake of the other amino acids? And in the paper, you can read an example of the calculations we do to show that that could be the case. Now, the last point I'm going to make is this is a model, this is a theory. If you in the paper that's in the packet, what we were able to do, and what I've now been seeing done at other centers since this report's been out, is you can correct the branched-chain amino acid deficiency syndromes in patients by lowering their medical foods and lowering their amino acid intake. To get a patient that was once much more than the DRI for their whole protein, plus maybe getting an equal amount of medical foods, you could take that same patient by dietary manipulations now and get rid of the amino acids and reduce the medical food intake drastically and then drop their total protein intake. And you can normalize their amino acids. And we did that in the paper. And there's a vignette of 2 patients treated as such that are in the appendix to that paper that I mentioned. So there's some evidence for this theory. That's how you get the evidence. You treat the patients. Okay, so the conclusion, my concluding remarks would be, medical foods can have iatrogenic toxicity. They are specially designed to treat patients with inborn errors of metabolism or other medical conditions. And I am not at all saying that medical food should not be used. I'm just making the point, and I think it'd be interesting to hear about the comments and discussion from our experience. Too much medical foods can produce an iatrogenic toxicity syndrome in MMA. It was unrecognized by the developers of that medical food because they didn't do a lot of research studies to test it. It's not required. What should we do? Well, maybe we should reformulate some of the medical foods and test by the indicator oxidation amino acid methods that we heard a bit about for effects on oxidation to see whether or not if you're giving someone a medical food, are you perturbing that beyond the static measurement of a level? An isotopic measurement is much better. And there's ways to do this. These are the things, this is research. And then the broader question I would pose to people for discussion is whether or not research and other proof of concept studies are indicated for medical foods in general. So with this, I will close and acknowledge the great support we have received from all the patients, families, referring physicians, genetic counselors, and dietitians for our studies over the years. I'm quite fortunate to be a member of the intramural research program where we can do these studies. We're funded to do the study. So we could do the study. And I'm in the Genome Institute, which is my home institute, and they've been wonderful supporting my program. Oh, I keep doing that, sorry. I have to also acknowledge that this work really was led by Irene Manoli, who's a biochemical geneticist in my group, who really is the one who really figured this out. If someone wants to hear about a wild theory about branched-chain amino acid oxidation and perturbations related to MMA, talk to me at lunch. It's probably like a 10-minute explanation. It might be right, it might not be right. That was my theory. I don't think I was right. I think she was correct, and she's the one who figured this out. And we have to give her credit for that, as well as other members of my group and our dietitian, our great collaborators at the NIH Clinical Center. With that, I will stop. Thank you.